Oh, are we live? I think I missed the changeover. Sorry about that, everyone. Good morning, good evening, good afternoon. My name is Jen Guile. I'm with NGINX Product Marketing, and welcome to our third week of Microservices March on Kubernetes Networking. I am joined here today by Chris Nesbitt-Smith. Hello, Chris.
Hi.
Chris is going to be walking us through the Microservices Security Pattern. I'm pretty excited for our demo today. He's going to show us how to hack an app using SQL injection and then protect it in a couple of different ways. If you're following along with the Microservices March program, again, we're in this third week. You can go back and catch weeks 1 and 2 on demand, and then definitely come back next week for advanced Kubernetes deployment strategies, where we're going to be looking at a canary deployment. And so if you are interested in participating in Microservices March, each unit has 3 components: the live stream, a collection of technical reading and videos, and the hands-on lab. The collection of reading and videos is linked in the YouTube description. And then the hands-on lab requires registration. Just head over to nginx.com/mm. And if you're up early with us, or later as it is if you're in EMEA, join us on Slack for questions. With that said, Chris, give us a quick intro. I think this is your first time officially on the Microservices March NGINX stage, but we've had you backstage for the last couple of weeks answering questions.
Hi. Yeah, it's been a pleasure. Thanks, Jen. So thanks for joining me today. Welcome. It'd be great to hear who you are. So please leave a comment, say hi, introduce yourself, tell us where you're joining from, your favorite color, your mother's maiden name, date of birth, credit card details, etc. This is a security talk, after all. My name's Chris Nesbitt-Smith. I'm an instructor at Learnk8s and a consultant at Appvia, and a tinkerer of some open source stuff in general. I spent a fair chunk of my professional career now working in UK government, where terms like defence in depth and zero trust are found in many a meeting note. If you've got any questions, please do drop a comment below. I'm joined by some friends from both Learnk8s and NGINX who will be helping me out. If we don't get to answer it, or you're not watching this live, then we will do our best to respond as soon as possible. Given this is an NGINX event, I imagine you're probably here because you maybe run some kind of web service of some sort. And I'll make a leap to assume it's not just a static site. So it probably has some sort of interaction, bit of search, contact forms, product catalog, shopping cart, or similar. So to kick things off and give you all a head start, I'm going to invite you to hack me while I explain some theory before I then pray to the live demo gods and walk you through a couple of hacks and some mitigations to that. So please start your engines. I've one polite ask, and that is to keep things fair and allow everyone to join in, that you only do explorative work and don't try to carry out any destructive attacks, which includes running any aggressive automated scans. This is an intentionally vulnerable web app, and as such, you can probably do all manner of bad things that would ultimately only ruin the fun for other people to enjoy. So the URL is on the screen now, and with a bit of luck, it should hopefully remain in the lower section of the browser, of the video, and may the odds ever be in your favor. So OWASP periodically publish their top 10, which is a broad consensus from the security community of the most critical risks to web applications. And that's based on current trends and intelligence that we have available to us. I'm going to be talking about injection, which, while down 3 places from its #1 spot, which it's held for the last 14 odd years, is still really important. And as we'll see, actually quite common and reasonably easy to mitigate against, even when the app itself has vulnerabilities that you might not know about yet. If you look beyond great services like, say, Google Analytics to your actual server logs, you'll probably find all sorts of non-browser traffic hitting your web apps from all over the world. And typically, you can expect to start receiving traffic from bots and malicious actors all over the place, looking basically to suss you out quite soon after presenting yourselves to the great unwashed internet. We're going to focus on SQL injection, which, while not the only, is still a very common form. The astute amongst you might find the other injection vulnerabilities we've left open in the application. Please do take bragging rights in the comments section as you find them, but to keep things fun, again, please, no spoilers. So a quick refresher. SQL, or structured query language, is a commonly implemented interface to a table-based database. So you'll likely have come across this with, say, MySQL, Postgres, SQL Server, and many others. There's a lot more to it, but tables, in short, can have columns and rows, and with a bit of syntax, you can then query them. Even if you're using, say, an ORM, you'll normally find under any kind of clever presentation thing in your code, the thing that actually goes over the wire between the app and the database is some variation of a query that looks like this. Because of that, it's really common for mistakes to be made in the implementation, really common. But it's not all doom and gloom. There are some things that we can do to provide just a first line of defense. But first, let's look at some of the offense. So web apps take an input in a number of ways. Commonly, even contact forms, for example, on websites will often have interactions with databases, potentially within a CRM, for example. But however it happens, because of the HTTP protocol, you're limited to a number of ways if you, for the minute, ignore WebSockets, which is way more involved. We won't look at that, though many of the same principles can roughly apply. There's some obvious methods, but really they're arbitrary strings we agree on have an expected behavior. If you actually look at a request payload, it looks something like this, which has a few places where you can provide something that the server will interpret and then act on accordingly. And for the sake and simplicity of this exercise, let's just assume that log4j and alike recent issues weren't a thing, and stuff that might only ever go to a log file won't hurt you. So the first line here is the path, which you'd see in the browser. The other is the request body, which contains the contents of something you've probably filled in a form and submitted. These are some of the key areas where you'll see application logic and developer code existing and evaluating the inputs on. So that might be checking user credentials as part of a login, searching for something, or indeed kind of uploading your kind of holiday snaps. So that code might look something like this, where you can see we've just basically concatenated the string together to form a query. The problem starts to become visible when, like our code here, we don't actually sanitize the input, and that simple string concatenation starts to hurt you. And the query you send your database ends up looking like this. That's beginning to not look very good. So what's the actual risk, you might ask? Well, it can start to go wrong real fast when someone breaks out of those templated queries, and that can look something like this. So by simply providing kind of that end quotes, I can extend the query to actually do whatever I like. So with this, I can carry out any action on the application and to the database, including some destructive ones. I could insert or update, potentially affecting the integrity of the database as well. So maybe I add a row into the payments table to say I paid for an order. I didn't, and so you ship it. I could carry out potentially a ransomware attack by actually going and encrypting all of your data and then offer to sell you the private key. You might have backups. You might notice it before you ship the order, but what about all the data? Well, how might I then try and steal that? Well, there's a few ways. I can either try and get, say, an error message like this to return the output I want, or I can manipulate the query to return the content in some other fields or update the tables to include all sorts, so I can pick it up from somewhere else. Or maybe you're running an unpatched database server that has maybe a well-known remote code vulnerability, or I've got a 0-day up my sleeve and I can exploit it that way, in which case I might have control of your database server now. Okay, things are beginning to look pretty scary, right? So don't worry, we'll get through this together and we'll figure some things out. So the obvious answer, quite clearly, is we'll patch your applications, right? But you can only do that when you know about it and you're in control. Well, what if it's a third-party app or one that you don't know about yet? What if there was a way that we could intercept and filter traffic that contained some obviously malicious queries before our applications came to it? Well, we could look for the obvious things like SQL commands such as select, insert, truncate, and join for all the basically any terms that we wouldn't normally expect to see somewhere. In the before times, you might have reached for things like a web application firewall, either physical or a virtualized appliance, or maybe using NACC, mod security, or some other kind of WAF software product. Well, welcome to 2022, where Kubernetes is seemingly the answer for all that ails you. So you'll be pleased to know that if your application is a Kubernetes running in a Kubernetes cluster, there are at least a couple of places we can apply some of this configuration. Best practice dictates that we only run a single process within a container. This allows Kubernetes to manage the limits, requests, and such. To get around this, we can adopt what is commonly referred to as the sidecar pattern, which is when we have more than one container in a pod. So these act as helpers. Because it's within the pod, it scales linearly with the application. So when there's multiple replicas, that you end up with multiple kind of instances of the sidecar and the application. And ultimately, that pod needs to fit within a single worker node as well. Perhaps one of the more well-known use cases for this is in service mesh. So things such as NGINX service mesh, other service meshes are available naturally. In this pattern, you'll find a sidecar container to all your pods, and they're proxying traffic in and out to the sidecar containers of other pods, which allows you to then separate your applications from all the boring stuff around certificate generation, signing, rotation, trust relationships, etc. And that's all without your app even being aware that it's benefiting from a greater level of security. So as far as the app knows, it's just talking over a regular unencrypted connection. If you've ever tried to run even just a local PKI, you'll really appreciate some of the heavy lifting that this sort of tech can achieve. So back to our application and our pod, where we can add an NGINX container. So again, other reverse proxies are available, and we can expose a port from that container instead. We can provide some configuration to the proxy, so that, the connection, so that it filters some of those kind of well-known keywords in the URL that we know to look for and know to not like. Wrap it up, smack it on the bottom, and send it on its way. And with a quick check, we can now see that we can now confirm that our application isn't vulnerable anymore. Well, I said a couple of ways. Well, what are some of the others? What I didn't tell you is this cluster is using NGINX ingress as the ingress controller. Naturally, again, other ingress controllers are available and have similar capabilities to configure them. So with a sidecar design, we're basically adding an extra hop for all of our traffic since it's actually already passed through an NGINX. So if we revert back to our first pod that didn't have the sidecar on it, and we look at our ingress configuration, we can actually add the same configuration chunk that we saw as our as the config for the proxy actually into our ingress configuration, just as an annotation, as you can see on the screen. Again, apply that, and we're all good. So this is the point that I now put my neck on the line and try and demo some of these principles for real. So what we can see here is I've got a kind Kubernetes cluster. So kind is Kubernetes and Docker. So it means that I can just run it all within my local laptop and see what's see the estate. I've made a couple of tweaks. The only things, excuse me, that I customized with this is the port mapping. So this 30,000 that's here, if you can hopefully see my cursor, relates to the 30,000 up here, and the port 80 is here. So this basically means that when I go to localhost port 80 on my Mac, it's going to pass through to node port that we're about to create on the Kubernetes cluster, and then that's going to pass through. But otherwise, it's a completely vanilla kind cluster. So without further ado, we can see. So we need to create a few files. So we'll need we'll create the database first, just so that has a chance to start up. So obviously this doesn't really matter what we call them, but for the sake of simplicity. So this 3306 port that's here is the one that's kind of being surfaced from the DB application. So it's this one. 3306, if you're not familiar, is the default pass for MySQL or MariaDB in this case. And we pass it some other bits of configuration to tell it the database and password and whatever to make. But yeah, it's this 3306 at the bottom here. And then we're going to create a service. So it's wrong one. So this service defines this box here, and it's going to be pointing at the 3306 above and also 336 below. So the target port is towards the application. The port is what's facing up, as it were. And we name it DB, so that allows us to then pick it up on just on a DNS entry as DB. Okay, so we'll just apply those. So the database, which might take a little bit longer than our app, starts creating those. Cool. Okay, now we'll have a look at our application. So similarly, we'll need to make a deployment file and a service. So if I do app deployments, so this is the deployment manifest. You can. This is the container image. If you wanted to kind of play along yourself with what we've done, so that's there, and the container port. So our application is listening on port 80. So the port 80 is the one that's kind of just above our app. That's here on the left-hand side of the screen, the diagram. And we're just going to give it some bits of configuration so it knows how kind of where the database is. So it's on DB, so that that resolves as a DNS entry, and the credentials on how to talk to the database. Okay. And also we need a service. So this to walk through this, the target port is the port down here on port 80. The 30,000 is the node port that's going to be surfaced back up. So that connects to our kind configuration that we put in that allows port 30,000 to be accessed. And yes, and the port 80 is what kind of points down at the application. So that's the target port. Okay, and then we can apply those. Okay, and if we just do get pods, right? Okay, phew. So we can see that these are hopefully both running. So let's see if that works. Okay, cool. And breathe. So we can see here, if you looked at the Heroku app, it's exactly the same thing. It's just a simple product catalog that exists, so you can kind of navigate through and kind of look at some products. He says whilst it hangs, fine. So there's a few things that we can see here, and the first one is that the the product is just a enumerated number. So, for example, if there's a product that maybe isn't released yet, you might find that potentially someone's put like a where part onto that query to filter down. So on the listing, so you might find that you can navigate through just by enumerating up the list. So that's one of the first examples that we can see. And we all can also make a reasonably educated guess to assume that the 5 is an ID of some sort. So if we remember back to what the query looked like, that probably is something looking like where ID equals 5. So the natural thing that we can start just to try and do is we can look at how we might be able to break that query. So let's try for example, like a single quote. Okay, well that doesn't change anything. It that's not going to break out the query. Well, what if we did something like a double quote? Okay, bingo. Well, we've now just found that not only were we right in our assumption of how that query was being put together, we're also able to see an error coming out of the application. So it's providing us some verbose erroring. So not only does that tell us some things about like how the application's running. So if we now see quite clearly it's a PHP app, we can kind of navigate, kind of see kind of where it is on the server. And we can see the query was the start of it. At least it gets a bit truncated, but you can see it was selecting a star, and you can probably guess that it's going to be from products, right? Obviously, the query might be quite long. There might be some complex things, but in this case, I can assure you it's simple. So what we can do with that is we can go to an address that looks like something like this. So just to walk through what's happening here. So extract value is a MySQL command that does some XPath, but basically we're not really using it for however it's intended to be run. We're using it because it has a side effect of outputting things to the error message for us to be able to pick up. So again, we can run that, and what we can actually see now is we can see the exact version of the database server that's running. So that's quite interesting. As earlier, we could potentially use that to if there was any kind of known vulnerabilities, if they haven't patched for some time, we could be able to start kind of doing some very targeted attacks based on that version. But the other things we can do is we can start enumerating through and do queries. So something like this looks like exactly the same thing, but it's embedding another query inside that. So what this one does to explain it is this is going to show us the databases. Now, it'll only return one thing at a time, but that's kind of fine. So what we can see here is that there's the first database. Sorry, the first database in this database server is information schema. Well, we presume that that's going to be true, given that it's MySQL. But what's the next database? So the next one is the SQLi training, which, if you remember from the configuration files, that was the database that we created. So we can kind of start to kind of reverse engineer kind of how some of it's hanging together. Now we know what the database is, we can also then start querying what the table structure looks like. So we can see that in this one, with a query that looks like that, we can see that that there's a users table on this SQL training database. So that's quite interesting. Well, there's probably maybe the sort of things you start assuming there's probably some sort of admin panel or something like that that's visible there, perhaps. So what could we do? What else can we do? So we can also see any other tables that are there. So the next table is the products table. Well, we knew about that one already, we guessed at least that there was some products. Now, iterating through and doing that kind of piece by piece can be quite painful and slow. So it's straightforward to obviously automate that. So with a bit of bash that looks something like this. So this just is a for loop of 20 for the sake of it. So it will query the first 20 columns from the products table. This particular query is structured to do. So again, with that, well, I can now see that there are 5 rows of sorry, 5 columns in this table. So it shouldn't then take much imagination to think about how you could extend that kind of ugly bash to start extracting all sorts of other things out. So all of the actual contents, those tables as well, and anything else in between. So that's like error, kind of leaking things out through the errors that are surfaced to you. The next one thing we can look at is kind of what's called as a kind of union leak. So this is taking advantage of part of the structure of the database, sorry, how the database kind of syntaxes its query. So what we can do with this is like -1, kind of -1. The product ID doesn't really matter, but the important bit in here is the we map in the users table. So where we're looking to see a user that has an ID 1, we want to try and find out the username. Now, the trick with this type of query is you have to match the number of columns in your response, otherwise it won't work. So if I kind of add in and do a few more, we can keep going. But we already know the answer because we know that it's selecting star from products, and there are 5 kind of columns in the products table, right? So we kind of gleaned some of that already. So by doing this, I can select, and I can select the same thing more than once. There's no harm in that, in order to pad out to get to the 5 columns, so it matches the same format. So we can provide like username, password. So there's 5 columns that come back. Bingo. So we've just found that not only have we got an SQL injection vulnerability, we're not doing anything clever like hashing the password. So I don't even need to go and look this up in a rainbow table or anything. I've kind of got the root password to be able to do what I like. This is kind of obviously a reasonably bad day. But what else could we kind of look at exploring doing? Well, we can obviously add things to the database as well. So by kind of ending the query that we had, which was the kind of select where ID equals 1 on the product, we can bung another query at the end of that. So in this case, we're going to insert a new product. So I could go, this could similarly be updating the price of an existing one, or it could be inserting a user or any other sorts of kind of challenges to your kind of integrity that are going to be bypassing any application logic and just writing things to the database. So we're not going to see it here, but we will see it down here. So we've now got a new product called Hack, which is interesting and a thing. But what else could we do with that? So the obvious is where we kind of start. We can start exploring what else we can do. So if the front end of the application doesn't filter what the database gives it, so if it just shows the content straight from the database and just trusts the database is going to be sanitized, we can actually start doing some things like this. So what we can see here is we're going to put in a script tag into, and in this case, we're putting it into the product name. Now, this becomes a big problem because every time that you even just see the product name, if this works, we're going to be able to execute some JavaScript. Now, what that means is that we can basically do anything that the person looking at the page can do. So if that is going and buying something, or if it's going and looking at their account information and changing it or leaking some of it out that way, all sorts of manners of things that you can do. But in this case, we're just going to just be annoying and show an alert message. If it works. Cool. So now when I go to the home page, what we should see if it worked is we should see an annoying alert message. And we'll see that kind of everywhere that we go where the product name would have been visible. I'm just going to reset quickly so we don't get annoyed with that. But that leaves us kind of open to all manner of different attacks. So I could do an insert like this. And of course, no kind of presentation would be complete without Rick Astley. So similarly, you can imagine any other things that we can do, like we could truncate the tables, add users, dump lots of data into another table, etc. So let's have a look at kind of how we can start protecting and stopping any of this sort of attack without obviously going and fixing our application. So the first one we covered in the talk was doing the sidecar pattern. So let's go ahead and do that. So the first thing we need is the config map. So the app config map. So if you've seen NGINX config before, this kind of should feel reasonably familiar. So we are just making we'll see in a minute, but the what this will look like is it will look something like this. So we're going to run NGINX kind of with our app, and we're going to make our node port service points at port 8080. We're going to tell NGINX to run on port 8080. And NGINX is then going to point to port 80 of our application. So the port 80 is here, so where it looks at kind of localhost. It's localhost because it's in the same kind of network on that application, and it's listening on port 8080. And as I said, like it's going to be denying anything that has a quote and then a drop insert MD5 or anything else like that in it. Okay. So we can do, we need to edit our application as well. So I'm just going to grab the bit of the screen, right. So here's our sidecar container. We're calling it sidecar, calling it proxy for the sake of it, doesn't matter. We're using just NGINX. We're telling it to the container port is going to be 8080, and we're going to mount in that configuration that's called kind of the configuration is called sidecar. So it mounts that in as a volume. So NGINX just picks this up. So this is just the vanilla NGINX, but with a bit of kind of tiny bit of config applied to it. Okay, and then we can do, so what we'll do is we'll bring up one of those one of the bad queries that we know shouldn't work, right? So before I apply it, so this works, right? So what we want to do is we want to get to a point where this fails. So we can do kubectl apply dash app config map and app deployment. And then, okay, and that should, with a bit of luck, if I've done it right, thinking, hopefully. I haven't not changed the service right, of course, right, my bad. Make the service point at the right port. So at the minute, the service, foolishly, the service is actually still pointing at the application on port 80. So I need to make that point at the NGINX instead. Okay, right. Now if I've hopefully done it right. Okay, cool. Phew, okay, it works. So through this, we can see that we've just written it, changed an NGINX to use that to buffer the connection, proxy the connection through NGINX, and do some simple evaluation on it. So this would allow, say, if we knew that the application had some vulnerabilities, or it's a third-party app, or anything like that, we'd be able to kind of see that here. Okay, so now what we can do is the other pattern that we saw was putting that in the ingress configuration itself. So we just undo what we've just done. So we can edit the service. So what we're going to try and do now is we're going to try and achieve a pattern that looks like this. So we're going to change our service that's here to be a cluster IP service, because we're going to be using ingress NGINX to provide the front door, as it were. So we can edit our service here. We can drop the type because cluster IP is the default. And we can say that we want to port back to pointing at port 80. So that's going to point at our application. so we can do that. So we can do, we need to delete that because the type of service is an immutable property. So we can do delete service app. So, excuse me. We can drop the bit from our deployment. Okay, so we can do plus apply deployment. Okay, and now we're just going to add NGINX. So we're going to use Helm to do this. There's a couple of tweaks that are applying the configuration that we're putting into this. So the node port here is port 30,000, which is the port up at the top. And we're saying we want a node port service, and we're enabling snippets. Now that's going to become clear why in a minute, but that's how the annotations are allowed to work. And I'm setting pull policy never because I've already kind of embedded the image for this, and it saves you waiting for my machine to pull container images down and the risk of that not working. Okay, so with a bit of luck, we'll provision that. See that, yeah, so I've already had those images. That's already running. So I should now be able to see 404. Now that's to be expected because we've not provided our ingress configuration yet. So the next piece is the application ingress. So that will look something like this. This is just the configuration that's going to tell it to a point that's listening for things connecting to the host localhost. And we're going to point to the service of app on port 80, which is what the service is listening on, and anything from like / onwards. Okay. So now, great. Okay, so we're back to where we started. We've not put in any of that configuration to protect anything. We're back to just, instead of the application being kind of directly exposed, we're now using NGINX ingress to apply that. I've probably used those interchangeably. There are two distinct configurations. That's ingress NGINX and NGINX ingress. We are using NGINX ingress as part of this for the sake of trying to clarify that. But yeah, apologies if I've confused. Okay, so where were we? So we've got our application here. We can prove that it's still vulnerable. We put our thing in front of it. So now we need to take that configuration that we had in our oops, if I can type map. So we just all we want to do is we want to take this bit. So I'll put that on my clipboard and provide that to our ingress configuration. So the trick to that is that you can apply annotations. Now, most other ingress controllers have similar capabilities of how you can provide additional configuration through the through annotations. So what we can do here is we can do annotation, a test of whether I can both spell and type. nginx.org/server snippets. This was that configuration option that we turned on to allow this. So we do that, and just tidy up the indentation so that it. Right. Okay. So again, the same NGINX configuration that we had, and it's just going to dump this kind of block that we've added blindly. Now, you need to get this right. If you mess it up, you can break the overarching NGINX for the whole thing. You can do all sorts of weird things. So we should trust that people are doing this right. Okay, so we can do that and apply. And now with a bit of luck, I'm crossing my fingers, bingo. So we now see a 403 forbidden, and if I try and look at the application as the original author intended, back to this. Now, we'll see any capacities that have been already added to your database are still going to be there. It's not going to retrospectively fix anything, but it is going to kind of provide some kind of a layer over the top of your application that can provide you with a bit of protection. And there, that kind of brings us to the end of our live demo. So yeah, thanks so much for your time. Hopefully you've been enjoying the great Microservices March month that NGINX has put on. Please do follow me on GitHub and cns.me. Ultimately just points at my LinkedIn. The original content for this talk is available on the NGINX blog, I believe. And you'll find some other kind of great kind of related resources at Learnk8s.io. Again, if we've missed kind of any questions now, or you're not watching this live, please bear with us and we will do our best to respond to them now. Hopefully Jen is still here.
I'm here. I'm back. Okay. We have a couple questions in the chat, and then we have some common seed questions. So let's go ahead and just go side by side here. We don't need the slides hanging out. Thank you. Okay. So a lot of these questions are why use one method versus another. And so let's start with the question about why not use a WAF. And so Armand, how is this different from a WAF? And then Cesar asked, will it include something more in depth with app protect? And so what I'll say first is we're only showing our open source tools in Microservices March. So we don't explicitly get into NGINX app protect WAF, but you're right. Using a WAF is absolutely an option here. So Chris, how is what you've shown here, both the sidecar method and the ingress controller method, why choose that instead of or in addition to a full-fledged WAF?
I mean, as with everything, particularly security, like it depends, right? So with this, we've applied like a blacklisting method for stuff that we know about. So you might find that you've got some off-the-shelf product and you become aware of a vulnerability in it, and this could provide you with a kind of a short-term quick fix that, as we can see, we can apply within a couple of minutes without touching anything on the application, without potentially kind of going into kind of larger bits of configuration. If you don't already have a WAF running in your estate, then yeah, it kind of gives you a position and point to do that in, as we've seen in like at least a couple of places. There's plenty of good virtues about kind of having a WAF, but you may find, depending where it lives, if it lives kind of outside your cluster, then that might be you might find that just within your organization quite hard to then get configuration changes to it. So that could be a good reason why you might want to have some bits of config locally. You could also flip to having, whereas this was a blacklist, you could whitelist the sorts of traffic that you wanted to do. Again, you could probably apply that configuration up outside, but this sort of pattern allows you to kind of deploy this all with your application as you apply that. And yeah, you might find, depending how your clusters run, if you've got multiple teams sharing it, you might find that like that snippets configuration isn't enabled, or there's some other ways that you might be able to achieve it. That's in a way, because as I was saying when we were editing that, it's possible to break the overarching NGINX, which would be bad, and break other people's applications if you've provided some broken syntax. It's just concatenating those blocks together. There's no particular validation kind of going on as far as I'm aware. So you've got the ability to have a kind of reasonable blast radius outside because there's no validation on it. So yeah, it depends on what the landscape of what your environment looks like and whether you've got other things going on. But yeah, like there's pros and cons all over the piece about whether you have like a WAF, because if you do that and it's like outside the cluster, then you've got your TLS termination is happening kind of way above where the thing is. So you end up with kind of end-to-end encryption concerns and like re-encrypting traffic and repeatability of that and etc. So yeah,
that's all there is.
Yeah, I mean, there's a lot of considerations of like where you'd put these controls. The answer's probably in more than one place. So you might just have like a broad level WAF that covers like as a catch-all that might run in or out the cluster. And then for targeted things like this, where we've just found that our application has a problem that is not protected by the overarching top WAF, we can just use something like this to block it. The snippet that's there is by no means like a complete answer to anything. It's more just showing how you can, how you can manipulate stuff. So you don't just take that and use it on prod traffic and assume you're fine. But yeah, it presents like an example of how you can block and manipulate the traffic being moved around.
Yeah, so we'll drop a link to NGINX App Protect WAF since there have been a couple of questions. It can be deployed both outside the cluster as well as inside. It can be deployed in the same pod as the ingress controller. And so that can let you do a lot of powerful things. But the ingress controller can also be used for things like method and path-based routing. So, and it's just different things. So I think we had a related question about using this sidecar method versus a service mesh.
They're kind of the same thing, I guess. So like service mesh is using a sidecar pattern, right? So it's you don't see it like in your deployment, but behind the scenes there is an extra container being added. So depending which service mesh you go for, they'll have various bits of configuration. They might give you the ability to do, certainly within this is basically just path-based filtering, that you might be able to actually land as configuration within the service mesh itself. But yeah, this is service
it's
mesh.
Like a mini mesh, huh?
Yeah.
Yeah, so I mean, the benefit with the service mesh would be you get the things that come with a service mesh or with the mesh, observability and stuff. So we have a couple questions in here about how much overhead might be introduced by a service mesh. So specifically by NGINX service mesh, I don't know if you've looked into that one. I know we do have the comparison table from Learnk8s. Maybe we can drop that link in the chat.
Yeah, I think there is some bits of research that I know Daniele at Learnk8s put together. I think it was him that put it together anyway. So yeah, there is some bits of stats. Obviously, you guys can talk to kind of what NGINX's commercial offering is. It varies. Ultimately, like you are stepping through extra hops of your traffic. It all depends on kind of what your traffic is and how and what your kind of threat model looks like to whether that's a thing that you care about. I'd say like debugging traffic that is moving through a service mesh, and like when it all goes wrong and something's really with the lower levels of like networking, and you've just got another thing to keep in your head of a mental model. That hurts. So like I'm generally a fan of like keeping it simple. So like if you needed to apply something like this, doing it kind of in as a simple kind of one thing in one place. So if this was patching a known vulnerability whilst you wait for the vendor to go and fix it or your app team to go and fix it, it provides some kind of like a quick fix that's a short term. I wouldn't necessarily advocate having a sidecar like this as a long-term answer for things.
Yeah, that could get kind of heavy if you have to, get in there manually and change it. So let's see here. Another question, can we use solutions like Open Policy Agent to restrict access to different pods and secure east-west traffic?
Yes, with a service mesh. So like that's kind of creeping more into service mesh. I mean, you could use this config to filter the sources if you wanted. If you just want like the simple answer, then use like network policy, which will allow you, as long as your overlay networks, your CNI, so your container network interface, as long as that supports network policy, then you can use that to filter what pods can talk to what other pods. And that's at the kind of simple side, like actually with real network controls, and it's all done kind of kernel level with how the IP tables or IPVS is implemented, and not at kind of a higher end user space type level where kind of service mesh lives. The service mesh can do all sorts of other interesting things, like deal with, as I was saying, like encrypting the traffic that's moving across, and handling all of the certificate trust and relationships. But if you don't care about that, or that's overhead and burden is going to hurt you, which it, depending on your needs, might, then I'd apply it first as a network policy, and then other things that you want to add on top to actually kind of provide more kind of fine control.
Yeah, we've shared a blog in the chat on how to choose a service mesh. We have a checklist that we include in there that kind of helps you decide if you're ready for one, because definitely no matter how much the maintainers of the mesh try to make it simple and easy, it's going to add overhead, right? And you can't pretend that that's not a consideration. So that'll help people determine if they're ready. Let's see here. We have one. How many gigabytes of RAM do you need for this?
NGINX and other similar things, like in this case, are small. I've not described any of the requests and limits on any of this, just to try and keep it so that the config, you could see them in the screen when I was doing it without like needing a magnifying glass. But yeah, naturally you'd like apply limits and requests. I've not tried it, but like NGINX, so the last time I kind of looked, it doesn't need very much at all, depending on your traffic kind of going through. So if you were applying it as a sidecar, it's going to be tiny. If you're doing things like TLS, like with a service mesh, then you'll see kind of more in this, like a little bit more in the sense of compute. But that's all largely accelerated these days. It's not like the old days where you'd think about like the CPU concerns of like turning encryption on. Like we're kind of past that sort of time now. So I generally say not much. Like your application is going to be the bigger beast. I'd be kind of inclined to single kind of digit kind of megabytes would be fine for NGINX most likely. But benchmark it. It depends on as well, like your application, on whether you're scaling kind of horizontally your app or vertically. So if you've got like many small instances of your application and they're only handling like a few dozen connections or a few hundred connections or whatever, then a kind of very small one. But if you've got one single big monolith that's handling all of the traffic, then you might want to be a bit more generous with the resource that you make available to NGINX.
NGINX
or whatever reverse proxy that you apply ultimately.
Yeah. NGINX is really small. We usually test performance based on how much latency gets added because of things like drop connections or timeouts or errors, whatnot. Okay, we have a question from Roxana. Is there a demo with exploits based on broken access control? We don't have one. Do you have one?
No. So yeah, this one was just on injection and going through SQLi. There's plenty around, but yeah, not part of what we've put together for this.
Not specifically that one, yeah. Let's see. Do we have any other questions we've highlighted in here? Bear with us. We're coming up toward the top of the hour, so we'll get through as many as we can. Oh, okay. We have another question. What's the advantage of using the sidecar container pattern over having a separate deployment with the reverse proxy?
I was coming back to kind of what I said. There's a few kind of points. So if it's a sidecar, it's going to run as it's always going to run close to your application. So if the networks hit your app, there's not a chance that it's going to hop over to another node and the traffic's only going to be landing in one place. You're not going to kind of hit the proxy and then bounce off to another node without kind of being able to control that. So it's always the traffic's always going to come in and just be the two things that are going to be dealing with that traffic are going to be there. So you won't have unnecessary hops, which can be advantageous. Usually any of these reverse proxies, they start really quick, so that shouldn't really be kind of a bit of a concern. Your app inevitably is probably going to take longer. The life cycle of it is going to go with your pod as another advantage, kind of why you'd go down this way. So it will scale with it. That can work for or against you. So like it's benchmarking, I guess, ultimately in your situation. And if you find that, like I'd say that the sidecar pattern is probably the easiest. But if that's not working for you, then yes, you can obviously have a separate deployment or whatever that's running that proxy for you, depending on kind of what your needs are and the scaling. But you're unlikely, as we kind of said, like the footprint from NGINX or any of its kind of counterparts as a reverse proxy are small, so you shouldn't really have a good reason why you'd need to scale that differently to your application too much. But yeah, like your needs may vary, but I'd probably say go with the sidecar pattern first, because it's not expensive and then keeps that configuration all together so you can see it in one place.
Okay, we have another open policy agent related question. As we restrict and isolate traffic using OPA for certain workloads like PCI DDS, can we restrict? Can we restrict? That makes more sense.
Again, like I'd say use network policy first. OPA and like any other bits of policy controls to like control the traffic moving around the network tend to be done with requiring more introspection into the actual content itself. So that's where kind of service mesh comes in as a thing, because it's doing kind of looking at that more and can do more clever things. But without not being kind of a PCI DSS kind of expert or whatever, I'd say that you should probably be able to achieve most, if not all, of the kind of segregation using network policy, which is going to be, depending on your CNI, is going to be configured at a lower level to what you would then be able to layer on top any of the benefits with service mesh. So kind of any of the TLS, kind of mutual TLS that service mesh might give you, or indeed you could roll your own, is going to be sat on top of that. But your actual kind of more hard kind of network segregation is achievable with network policy, presuming again like your container network interface supports it and how it implements it as well.
Okay, I think we have time for 2 more questions. So just anyone who's still listening, if we don't get to your question, we'll come back into the chat and answer it. So Theodore wants to know, how does the filtering affect the number of connections that the ingress or sidecar can handle reasonably? And what if we were trying to use auto scaling? So this is kind of a throwback to our first week when we did the auto scaling, right?
Yeah. Again, like the reverse proxies of any sort doing simple filtering, like on the location, you are far more likely, I would generally kind of hazard at, to struggle with load issues on your application where it's actually processing anything, rather than on the proxy itself, unless you're servicing static content, in which case you probably don't care about this sort of filter, right? If you've got something that's going to be evaluating the actual kind of code or the query and doing anything clever, then yeah, I would generally, as a rule of thumb, say that you're far more likely to see scale concerns and needing to scale up with your application, rather than like seeing a load on ingress as a general rule, both as a sidecar pattern and on the adding the rule to the overarching kind of NGINX. So if you use the snippet approach, then it's only a few more lines of configuration that's being applied to the to NGINX as the ingress controller. So again, it's a very small footprint for something like this. Okay,
so final question. I want to learn microservices, but I don't know where to start.
Have we got another couple of hours?
I know, right?
I guess it's hard, right? I guess some of the obvious things I'd probably say, like if you wanted to try and grasp it or try and adopt it, is take your big kind of monolithic application and then look at what's commonly referred to as a strangler pattern. So by that I mean that you take your monolith and then you take something that's small and provide that via a microservice. So that might be, say, if you've got your website and it's being hosted by, I don't know, some monolithic installation of, say, WordPress, for example. You could take like the /about URL using ingress and point that off to another instance of your application, or you could put the admin path behind a different ingress that's only open to your that's configured in different ways, so it's only open to kind of known and trusted connections from your office or whatever you might like. So you can start carving up your overarching kind of big application. In terms of like just microservices kind of as a general kind of theory, then obviously Learnk8s.io has some great courses, but I'm sure there's plenty of other ones, and NGINX have got some great material that's available for free as well. In that space, there's plenty of things around. But yeah, as a learning microservices is big. Martin Fowler is probably one of the most distinguished authors in the space. That if you go and look at his blog, that probably provides the most definitive and certainly authoritative answer on what it is and some of the detail around it.
Yeah, so I've shared a webinar link in our chat, our microservices fundamentals of microservices webinar, which was part of Microservices March last year, that kind of just goes over the very basics of what's a microservices and how is it different from monolithic containers, all that stuff. I think now is probably a good time to say Microservices March is also a good place to get a lot of this. You can check out the live streams that we've done for the last 2 weeks. So we started off with a cool auto-scaling live stream on architecting clusters for high traffic websites. Last week, we looked at rate limiting, and next week is going to be advanced deployment strategies. We'll be actually looking at NGINX service mesh. We've been talking a lot around service mesh today, but next week we'll get hands-on with it to do a canary deployment. So if you take a look at the description for this video, we have a companion blog that goes with it that has a whole bunch of resources. We also have links out to, let's see, what do we have here? We've got a whole bunch of stuff. The next live stream in the series, if you scroll back through the links that we shared earlier, we have our GitHub repo with the examples for today. So there's a plethora of resources. With that said, we're a couple of minutes past 9 a.m. Pacific. And so, Chris, time for your afternoon tea or dinner or whatnot. I think I'll go get breakfast. Thank you, everyone, for watching, and hope you enjoyed it. Thanks, Chris.
Cool. Thanks so much. Cheers.